Bismillahirrahmanirrahim. Students, this is the latest paper, February-March 2022. I'm going to solve this paper just for the help of the students. Question number one. This question number one is a speed time graph. Check the question statement. A ball rolls down a ramp and onto horizontal surface. The first section of the horizontal surface is smooth and the second section of the horizontal surface is rough. Okay. Figure 1.1 shows that shows a speed time graph for the ball. So this graph is given to us and there are questions related to this graph. The question number A, state the time when the ball reached the start of the rough section. So it's understood the rough section have a friction. So when friction will be there, then definitely speed will decreasing. So I suppose that this is the point from where the speed slow down, so rough surface is started. So I hope so. This is the point. I don't have a scale, so I will draw this line as a rough line. So I think so. This is the point, and this point is I think so. This is 2.2. So the unit is not given with the answer. So when you will write the answer, so please do mention your unit. So 2.2 second is a time when a rough section is started. Come to the part number B. In part number B, explain how figure 1.1 shows that there is no resultant force on the ball when it rolls along the smooth section of horizontal surface. So it's obvious. Examiner mentioned that shows that there is no resultant force. No resultant force can give us two answers, because you know that whenever we talk about a resultant force we always use a Newton's second law. So as there is no resultant force as given by the examiner, so it means if resultant force is zero, then either mass is equal to zero or acceleration is equal to zero. So we know that mass of the body is not zero, so definitely acceleration is zero. So you can answer the question like as the speed is constant, as the speed is constant, so there is no acceleration. So no acceleration. No acceleration mean no resultant force. There is another answer that you can give in that case, like as speed is constant, so force acting on the body are balanced. You can answer this question as also as force as speed is constant, so force acting on the body it's better to say that forces acting on a body are balanced. So both answers shows that there is no resultant force. Now come to the C part of the question. Using figure 1.1, determine the acceleration of the ball as it rolls down the ramp. Mean as you drop the ball from rest, then you need to calculate the acceleration. So I need some help from the diagram. So here is a point when body is dropped from the roll, because speed at that time is zero, and this is the maximum speed of the body gained. So if you check out, I'm just going to zoom this point. So check out this value from the graph. You will see that on the graph this value is approximately equal to 12.8. So acceleration, you can know, you know that acceleration is final velocity minus initial velocity divided by time. So we have everything, that final speed, our velocity is 12.8, it's better to say speed, and minus initial speed, that is 0, and the time taken to increase this speed uh, from 0 to 12.8, this is 12.8, it is 1.5. So divide by 1.5. When you will calculate, you will get the answer 8.53 meters per second square. Now the last part of the question, the D part. The ball start from the rest, okay, at the top of the ramp. Show that length of the ramp is 9.6. Now for this question, there are two ways to handle, because the ramp length of the ramp, this graph shows that, this graph shows actually the distance covered by the body, because it's a speed time graph, so area under the curve gives you the displacement. So if you calculate the area under this graph, you can get the answer. There are two ways. I can solve the question with both of two ways. So I can write that length mean the distance, or you can say, it's better to say displacement. Speed time graph gives you the displacement or distance. So S is equal to area under graph. So area under the graph, you know, 1 by 2, 1.5 multiplied by 12.8 multiply by 12.8. When you will calculate it, you will get the answer 9.6 meters. See, this is the area under the graph. This area under the graph gives you the length of the ramp. The second way, we can use the motion equation of motion. There is another way. This help you to calculate and give you the same answer. But if you don't know this equation of motion, then I think it's better to use this. Speed time graph is given to you, and speed time graph, area under the curve, give you the distance, and that distance is equal to length of the ramp. Second way, you can use that this equation, 2as is equal to final velocity square minus initial velocity square. As we already calculated the acceleration, I'm going to put the value of acceleration, that is 8.53. S is the distance that I want to calculate. V is the speed that is gained by the body from rest to the maximum, that is 12.8 square, and you know that initial velocity is 0, so I can place here 0 square. After calculation, use the calculator, you will get the value of S, that must be equal to let me give me 1 minute to calculate, and this answer that my calculator give me the answer 9.6 meter. So both ways you have to get this answer. This is the first way. I recommend you